Okey, Assalamualaikum warahmatullahi taala wabarakatuh. Salam sejahtera. Jumpa kali ini untuk kuliah kita yang kali kedua, di mana saya akan cover topik 3. Satu lagi example ataupun latihan berkenaan dengan topik 3. Ini topik 3 yang kita akan cover lah. Okey. So seperti yang apa yang tuan-tuan lihat di hadapan ni, kita ada yang kalau example lepas kita cover cantilever beam. Untuk kali ni kita cover simply supported beam lah. Simply supported beam yang awak tengok dia ada support kat sini dan dia ada support dekat sini. Okay, simply supported beam yang that been act by a load, concentrated load. Sini load yang pertama dan di sini load yang kedua. Di sini load yang kedua. Okey. Jadi in a sense, langkah pertama, step yang pertama, kita kena hafal formula yang paling normal lah, yang kita kena tahu, iaitu daya ke atas is equivalent to daya ke bawah. Force that acting upward is equivalent to force acting downward. Ini yang pertama, wajib kita kena tahu. Maka kita susun, apakah daya yang ke atas. Untuk kes ni kita ada A plus B equivalent tu daya yang ke bawah ialah 10 kN plus with 2 kN. 2 kN darab dengan jarak dia 6. Sebab ini ialah Newton over meter multiply by meter. So kita potong-potong, kita dapat Newton. Okay. So this is the first step that you have to encounter. Alright. Where the first step is you need to find RA and RB. You need to know what is the value, what is the magnitude. So by equate all the values here, within the equation, you have to rearrange the equation accordingly to you have to rearrange all the values according to the equation. So in my sense, I managed to get RA is equivalent to 14 kilonewton. At the same time, RB is equivalent to 8 kilonewton. You can try this, guys. Okay. So the first step done. So we managed to get RA and we managed to get RB. And this is RA and this is RB. Clear? So we done step 1. So we're going to proceed to the step 2. Alright, step 2 is quite easy as well. Since you already have the what you call that? You already have the RA and RB value. So it's going to be much more easier, yeah. So step 2 is we're going to find what? We're going to find the shear force. This is quite straightforward, easy peasy. Alright. So it's just simple as you need to draw a horizontal line which is identical to the beam. Kita buat macam ni lah. Kita buat macam ni. Alright. So here is 0 2 6 6 12, 16. Okay, this is the beam. Okay, same I mean like same way that I've been that we learned before in our previous class. You know, we plot a cantilever beam with their what you call that, oops sorry, with their what you call that, with their scale. So now we're going to calculate the shear force. So at 0 meter, what is the shear force? Shear force at 0 meter is RA, yeah, 14 kilo Newton. So we plot here, wait up. So you're going to plot here. My goodness. So we're going to plot here. Okay, this one is 14 kilo Newton. Up until what length? Up until 2 meter here. So we go up until here 2 kilonewton. Okay, 0 which is here, and then we add with 14 kilonewton, so we got 14 kilonewton at 0, and then it goes up until 2 meter. Then at 2 meter we got another force which is acting downward. That force is magnitude by 10 kilonewton. So therefore 14 minus with 10 kilonewton is going to give you here 4 kilonewton. Okay, and then we're going to proceed the load up until 6 kilonewton. Okay, so for this 6 kilonewton, this area, yeah, need to be a bit careful. Why? Because at this this point, it is a uniform distributed load. Since the load is uniform distributed, so they got some equation to solve it. All right, so the equation is for this case, at 4 we're going to minus 23 2 power of 3 multiplied by 6. Here is UDL. So 4 minus 6 multiplied by 2 is 12. So 4 minus 12 is equivalent to 8. So here is 8. So we're going to cross to 8. Alright, so if you want to loretkan, then you can loretkan. Alright, so this one is negative 8, and then from negative 8 we're going to further up until 16, and then my negative 8 you're going to plus with RB, which is RB is 8 kilonewton, so it goes back to 0 like this. If you want to hash it, then you just hash it this way. So this is how we managed to get what I call that, the shear force. Very easy. Okay, less than 10 minutes we managed to get this one. Okay, so I recap. First thing first, what you need to do is you need to calculate, or you need to find. Step 1, you need to find RA and RB. Once RA and RB you got, then you're going to proceed for the shear force. Shear force is very straightforward. We managed to sketch it, similarly to what we got, to what been plotted by me here. So it's going to be much more easier lah for you guys to follow. Alright, so we're going to proceed to step number 3. Let me erase this one first. Step number 3 is quite simple as well. Very easy. Not that being too difficult to handle, I think. Okay. So here is step number 3. You need to find bending moment or moment with dia punya tu Newton meter. Okay, similarly, simple, easy peasy. What you need to do, first of all, you need to draw a horizontal line. Draw a very simple horizontal line, then you scale it up. You scale it like 0, 2, 6, 12, and last one is 16. Okay, so in a such for the moment we need to find the area of this one, in order to calculate the moment. So for this case, at area A here, area A, how to calculate it? We need to find the area. So 14 multiplied by 2, that's why you got 28 here. Okay, that's why you got 28. And number 2 is 4. Let me erase first, for much easier for you to follow. Here is area B. Okay, so what is the height? The height is 4, and what is the length? 6 minus 2, we got 4. 6 minus 2, isn't it? Yeah, 6 minus 2, we got 4. So 4 times 4, you got 16. Second area, area B. And then area C here, we can, trapezium, rectangle. The way to find the area of rectangular, like this. Okay, we got 4 and we got 2. Okay, something like this. Okay, 6, and we don't know what is the area here. So 6 minus x. This is one is x. So I got 1/2 multiplied by 4 and multiplied by 2. So cancel out, so we got 4 here. Okay. At the same time, and area D here, same way as well. This one is 8 multiplied by 1 half multiplied by 8 multiplied by 6 minus x, something like that. So how we manage to get x equivalent to 2? Wait up, let me make it clear for you before we proceed to the other numbers. For the case of C and D area, since we got like this, so this is 4, this is x, and then for this one, this is 8, and this is 6 minus x. Okay, therefore for this case, in order to get the area, we need to find the area by using this equation, half multiplied by height, which is 4, and multiplied by the length, which is x. And for this case, half multiplied by 8 and multiplied by 6 minus x. So the very big question now is how to find the x. You can go by using this equation. Simple, yeah. So this is just some arrangement. 4 over x equivalent to 8 over 6 minus x. Yeah. Four over x equivalent to 8 over 6 minus x. Okay, where 4 is the height, 8 is the height, x is the length, 6 is the length. So you're going to equate this quite much, then you're going to get x equal to 2 meter. Very simple equation, yeah. So by this time, once you got x equivalent to 2, then you're going to sub in here and sub it in here. Alright, so at the end of the day, you manage to get, you manage to get 'B' is equivalent to 4 kilonewton, and then for D you're going to get 16, if I'm not mistaken, 16 kilonewton, isn't it? Yeah, you managed to get negative 16 kilonewton. Yeah, and then for E is same way. The height is negative 8 and the length is 4, so you're going to get negative 32 kilonewton meter here. So once you manage to get all this equation, all this number, yeah, so you're going to plot it, let's say for the first case, let's say 28 kilonewton, 0 plus 28, so you're going to get 28. So here you're going to go up until 28. Okay, and then 28 plus 16, which is 44. This one, let's say this one 28, and then we go 44. Okay, already add up 44, and then 44 plus 4, you go 48. Okay, 48 minus 16 is 32. 32, and then 32 minus 32, end up with 0 here. So more or less you're going to plot it somewhere like this, something like that lah. Okay, so if you want to hash it, you are allowed very much to hash it. So here is the bending moment diagram. So most probably there will be a question follow up where I'm going to ask you to find largest bending moment, which is for our case 48 Newton meter is the largest bending moment. Okay, so once you manage to get all of this example done correctly, then I think it's going to be not much problem for you guys to sit for your final year exam, or for your next process for industrial, for LI, you know, for LI, for work. I think it's going to be much more easier lah. All right, so if you don't mind, then I think I'm going to stop my kuliah at the moment. And then if you got any feedback or comment, then please let me know. Hopefully you guys will be okay, yeah. So up until next time, see you guys when I see you. Assalamualaikum warahmatullahi wabarakatuh.